So over time, over the next 90 minutes, that carbohydrate or that sugar that is now broken down is going to be released into the bloodstream and will raise the blood sugar level. As the blood sugar level rises to a certain point, the message is sent to the pancreas. The pancreas says, oh, let's bring that down. We need to use that as energy. We now have our chance to have energy brought into our body. We have this sugar. So insulin is sent out, which now increases the intake of that sugar into the cells. Receptors to the transport into the cell. On the average, about 50% of glucose is burned as energy right then and there. 10% stored as glycogen. Glycogen is nothing but a bunch of sugar molecules hooked together. The glycogen molecules are in two places in the body. The major amount is in the muscles, because when we start exercising, when we do that long walk, when we were young and we used to actually run, we needed lots of energy, and there was not enough energy, not enough glucose to maintain that energy in the bloodstream. And so the muscle released the glycogen. Little pieces just kept throwing that glucose out as fast as the muscle needed it. Then about 40% is stored as triglycerides. This is our long-term storage plan. If the glycogen is used up, now the body has another source called triglycerides that it can break that down and create energy. Now, that is how the normal real food carbohydrate physiology takes place. Now let's talk about refined carbohydrates. Refined carbohydrates is when you take out all the fiber. Sugar is usually added to it because processed food, the processed food industry likes to sell things. They know how to sell things. They know how to get people to buy more. That is, put sugar in it. So everything that's in a can or a box has added sugar, has refined carbohydrates. So now we have a refined carbohydrate with no fiber, so the sugar is absorbed very quickly into the bloodstream. The insulin is now released. The insulin thinks, well, the normal insulin secretion is going to take place over the next 90 minutes. So this level went up this high. This must be a huge amount of carbohydrates. So I'm going to release a huge amount of insulin to bring that down. The problem is there's no carbohydrate to follow for the next 90 minutes. So the insulin is too much for the short course of glucose rise, and so it drops the sugar too low. So an hour, hour and a half later, how do you feel after your sugar ingestion? Kind of tired and moody and irritable. You have any of those feelings? Never. Not in this group. Okay. Sugar goes too low. So there's two ways to get the sugar up. We have these glycogen stores in the liver. So it starts breaking off those sugar molecules and releasing it into the blood. Now that takes too long. Those of you who have your sugar up and downs, you know that if you wait an hour, that you'll feel better. But you've also discovered that if you don't wait an hour and you have a little piece of candy or another little sweet, it only takes 5 minutes and that feeling goes away, right? The hypoglycemia feeling, or the moodiness and feeling tired and all of that can disappear very quickly. So that's what we typically do. So the liver's releasing glucose. We take another glucose in. It rises up. The sugar level is seen by the pancreas. Too much insulin drops it down. Too low. We eat another sugar 2 hours later, bring it back up, and we're doing this swinging day in and day out. Once we do that for long enough, and that'll take years, but we do that long enough, and the actual insulin receptors on the cell membrane will start to disappear. They're starting to rebel. And the cell wall, as we look under the electron microscope, the cell wall of people in insulin resistance and getting into the diabetes now has a thickened cell wall. So that sugar can no longer be brought down because it can't get into the cells. So now the sugar stays up. And the pancreas sees the elevated sugar, keeps producing more insulin. The insulin does not take it into the cell. So now we have a high sugar level and a high insulin level. We call that insulin resistance. And if we go long enough in that process, and the sugar level gets up into the 120s, 130s, 140s, we now magically call that diabetes. So, how far did we get on our little list here? Anyone following? 7? Page 8. Okay. We are now on page 8. Did I miss anything? Anyone following along? Did I cover most of it? Okay, let's talk about healthy sugars, levels in the bloodstream. I think 75 to 80 is ideal. I think a number in the 80s is just fine. So 75 to 85, 88, I think is a reasonable level. Once that sugar level is getting into the 90s, then we're a little bit higher than I want to see it. Now, if you look at the reference range for the glucose, you get a lab value, and they have a reference range on the side. It'll say 80 to 100. Right? Anyone looked at those? Isn't that about the range, 75 to 100? I think that's what they do it. I think the 90s are too high. A healthy insulin level. Now, I noticed that the reference range for insulin just went up in some labs in the last month, because it used to be 0 to 17 is the normal reference range insulin level. And I just saw one 0 to 20. A healthy insulin level is 0 to 5. Once it gets above 5, we are now having a little bit more insulin than our body really needs to bring that down. In other words, the beginning of insulin resistance. Anything above 10 is definitely a problem. So, diabetes is once you get a glucose level of 140, or depending on who's defining it, 126. You get that twice in a row, you now magically have diabetes, as if the 120 or the 130 was okay, but now you magically have a problem at 140, as if it made any difference at extra 10 level. Very little. Well, let's talk about why we're so concerned about high sugar levels. High sugar levels in the blood permits the binding of that sugar to a protein. Sugar is sticky. We call that process of binding sugar to a protein glycosylation. Now that just makes us sound good. Doesn't it sound neat? You have glycosylation. All that is sugar hooking on. Now, those of you who are diabetic, you've heard of a hemoglobin A1C. That is glycosylated red blood cells. All they're doing is measuring the red blood cells and measuring how much sugar is on the red blood cells. And if it's above, I consider 5.5 up being normal. Once it gets around 6, it's definitely too high. Standard medicine will be thrilled if someone diabetic gets their hemoglobin A1C down to 6.5. It isn't until it gets well below 6 that I'm the least bit happy with where